In the following example, we start with a verbal description of a function and a physical situation, and then obtain an explicit algebraic formula. The ability to do this is a useful skill in solving calculus problems that ask for the maximum or minimum values of quantities. For example 5, expressing a cost as a function. A rectangular storage container with an open top has a volume of 10 meters cubed, or cubic meters. The length of its base is twice its width. Material for the base costs $10 per square meter. The material for the sides costs $6 per square meter. What we want to do is we want to express the cost of materials as a function of the width of the base. So the first thing we need to identify as to what's going on here is that we need to draw a picture. So drawing a picture of a rectangular storage container is what we have. We know that we have the height, we know that we have the width, and then recall here that the length of the base is twice its width, so that's why we have 2W. Now, the material for the base is going to cost $10. So the base is what we have here. And so this base represents $10. So we know that the cost of this is $10. Okay, and then we also know that the material for the sides costs $6 per square meter. So if we take a look at the sides, we know that all the sides here, so the front, this side, the side in the back, and then this side here. Now remember that it's an open top, so we don't have an open top for that. So we're not including that part of it, but we do know that we have 1, 2, 3, 4 sides, and that is $6. So the next thing that we want to do is we want to find the area of each particular item that we're dealing with. So we know that the area of the base is the following. Well, we know that the base has a length of 2W, and we're going to multiply it by W. But we also need to multiply it by the cost. So we're going to take the cost and multiply it by the base. Well, the cost of the base is $10. So we have $10 times the area of the base, which is 2W times W. So now what we want to do is now we want to be able to find the area of the two faces of the box, which are sides. So here is one side, which is the face of the box container, and then this is the second one. So we have two of them. So we have a total of 2. So that means we're going to take the cost of that and multiply it by 2 times the area of the face. So the cost of the sides we know is 6 times 2 of them, because there's 2 of them. And the area of the face is H times 2W. Now we want to be able to find the cost of the sides. So here is one side, and then here's the other side. and there's two of them. So it's going to be the cost times 2 times the area of the sides. So this is going to be 6 times 2, and the area of the sides is h times w, since we have two of them. Now this entire equation is going to represent or express the cost of the materials. So expressing the cost of materials means that we know that the entire cost is going to equal, well, this is 10 times 2w times w, which is going to give us 20w squared, plus this is 6 times 2 times 2, so 12 times 2 is going to give us 24, and that's hw, plus 6 times 2 times hw is going to give us 12 hw. So this was our first step. This is our second step. So now we still need to combine like terms here. So we know that the cost is going to equal 20w squared plus 36hw. Now in part 3, we need to go back and look at the question here. It says express the cost of materials as a function of the width. So that means we need to have this as a function c of w, which means that if we plug in the width, we need to make sure that all the variables on the right hand side has to be w, but we have this h that we need to write in terms of the width. In order to do that, we need to use the first sentence of this problem as saying that a rectangular storage container with an open top has a volume of 10 cubic meters. So if we look at the volume, it's equal to 10 cubic meters. Now remember that the volume is length times your width times your height. If we look at our container, our length, width, and height is h times 2w times w, and that's equal to 10. So if we multiply this all out, we're going to get 2hw squared, and that's equal to 10. And what we want to do is we want to solve for h so that we can plug in what we solve for h into that equation. So we're going to divide both sides by 2w squared. And so what we get for h is 5 over w squared. So now what we're going to do is we're going to plug this into this function. So now this is going to become 20w squared plus 36 times 5 over w squared times w. Well, if we go a little further, this is going to be c of w, which is equal to 20w squared. Okay, and 36 times 5 gives us 180. And we simplify one of the w's, and that's over w. So now this is our cost of materials as a function of the width of the base. So now this is c of w. Now the only thing we need to make sure of is that this w in the denominator cannot be 0. So that means our width has to be greater than 0. And therefore there is the formula of our cost function.